Good evening, everyone. Good evening, everyone, and welcome to October. That's why I tried to make that sound spooky. I see we have a few people still coming into their seats, so we'll take just a moment while they do that. But let me be the first, if I am the first, to welcome. What the heck?
Oh, you sat on it.
I didn't sit on it. Okay, all right.
My story's done.
What in the world?
The show's going so fast tonight.
It's break time. You know, we're going to take a deep breath and start over. Welcome, everyone, to All Space Considered at Griffith Observatory. How many of you are here for the first time? How many of you have been here before? That never adds up. There have to be people in here cheating. I just know it. So for those of you who have never been here before, we welcome you. For those of you who have never been to All Space Considered before, how many of you have never been to Griffith Observatory before? Just a few. Yeah, it's kind of hard if you live in Los Angeles not to have been here before because it's such a big landmark. But we're glad you got a chance and that you fought the Greek theater traffic and that you're giving up the Dodgers game to see this show tonight. So without further ado, let me welcome you. I'm Dr. Laura Danley. I'm the curator of Griffith Observatory and the host for this evening, along with Dr. David Reitzel, our astronomical lecturer, and Patrick So, our theater programs manager, director of our planetarium. And we, along usually with Tony, who's on a little bit of a hiatus at the moment, are your regular hosts for All Space Considered, our monthly program of space and astronomy. It happens on the first Friday of every month. So we are glad you're here. For those of you who've been here before, how many of you are members of Friends of the Observatory? Okay, that number is great. We want to see more of those hands. Friends of the Observatory is our sister 501c3 support organization that makes so many things at Griffith Observatory possible. Especially, I like to always call out our 5th grade field trip program for the 5th graders. So they can learn something about our solar system and learn something about science and become wonderfully well-educated voting citizens when they reach their 18th birthday. So that makes you want to become a member of FOTO, right? Friends of the Observatory. And how many of you are tax-paying citizens of the city of Los Angeles? Yay, taxpayers. And I say that because you pay my salary and our salaries. The observatory, Griffith Observatory, is owned and operated by the City of Los Angeles Department of Recreation and Parks. You may not know that. We're a city park, but just a very special city park with a very special facility brought to everyone by the tax-paying citizens of the city. So we thank you for that. Now, just quick notes, that is not an exit. Always, just about once per show, someone tries to go out that way. They run into a locked closet door, and then they come back up the stairs and feel very sheepish. So you don't want to do that. Then, if you try going that way, it does say exit, but that's an emergency exit. So if there is an emergency, we will guide you out. But that is also locked. So you'll do the same thing. You'll go there, find the locked door, and then you'll, kind of, oh no, I guess it's not locked because it's an emergency exit. So don't go out that way. You'll get lost. Trust me, you will not reappear until after All Saints Day. As a ghost. Let me also take a moment to say welcome to our audience on our YouTube event. Yay, YouTube. We're going to be having a special thank you to YouTube a little bit later with our guests. And you can leave your cell phones on because there is no signal in this room. And so, in fact, if you leave them on, you will probably lose battery because your roaming will be looking for signal, and then you'll get outside, want to call your ride share, and then you won't have battery, and you'll be so sad.
You'll have to walk out of the park.
Yeah, it's a long walk down the hill. You don't want to do that. So we encourage you to turn off your cell phones, but if you really want to keep them on, you can certainly feel free to do so. I think that's it for those kinds of announcements. Yes, we're getting to songs and swag in just a sec. But so no other of those announcements. Housekeeping, I don't think so. So, Bill, tell us about songs and swag.
Songs and swag, yes. If you're a regular, you know we play a game here during the course of the evening where we played music cuts coming in. I think there were 7 different pieces of music. Each one of those pieces of music is attached thematically somehow associated with one of the stories that we're going to be doing tonight. And the game is, if you see that, when you see that story come up during the course of the night, shout out the piece of music, the name, or any kind of way to identify it, and you win a prize. And the prizes are down here, spread out, and you'll be able to see what they are. We have all kinds of mission stickers. I want to say some of them are a little out of date, and I'll get to that in a minute, but like, Titan and stuff. But that just means that these are actually collector's items. So we have all kinds of stuff. We've got great information and a beautiful picture of Europa there. We also have one left of these. This is a New Horizons spacecraft paper model. You punch out all the pieces, follow the directions, and make your own New Horizons spacecraft. So that's, we also have many more of these beautiful James Webb Space Telescope posters. As I like to say, we all get a poster and put it up. Maybe someday they'll launch the James Webb Space Telescope. They will launch it. We had a guest. They're on it. They're doing it. And it's going to be beautiful.
They are on it, and they are doing it.
They are.
I'm going to go see it in like a week. I'll get a report on it.
Yes. Go back and see our YouTube show on that. I want to say two things in particular. Oh, I'm sorry, I forgot the calendars. The calendars, of course, that's everything. We have all kinds of beautiful calendars. Many of them are pocketbook-sized Griffith Observatory calendars. We also have NASA Mars Exploration Rovers 2017 to 2018. You're getting the idea here that these are all completely out of date. What happened to my paper that has the list of when these are good again? Does anybody know where that might go?
You don't have it memorized?
I don't have it memorized. I do believe 2017. The point is, reduce, reuse, and recycle. You can do that with calendars. Calendars are good again in the future. 2017 will be good again, and I think it's 2023. And that's not that far off. I wish I had my paper, darn it. I'm sorry. Okay. Anyway, all of these calendars will be good again. There are certain things that'll be off, like moon phases and stuff, but we can live with that. You get those from somewhere else. Anyway, that's it. The other thing there are two things I want to say. One, we do have guests tonight. During the presentation by the guests, we don't play the game, so don't be shouting out during the actual guest presentation.
I was going to say, isn't there one? I think there is one for their presentation.
Well, now we've done it.
Now, yeah.
Okay.
There's the big reveal. Anyway, enjoy the show.
Well, but then, I want people to get the prizes. So, as I said, first Friday of the month, and today is October 4th, because isn't that great? So we're going to begin a little differently. No launch to start the show. We're going to start with a sky report, and then another interstellar interloper, that's a little hard to say, update on Planet A. Anyone know who Planet A is? Earth. Thank you, whoever said that. Earth, that's Planet A. Just because later we're going to ask about Planet B. Is that an option? Then we have wonderful guests. We're very excited about our guests tonight who have been learning all about, a number of things, but for tonight's purposes, whether or not we can survive on Mars. And they're doing that because they have been working very hard to put together a new YouTube Originals program called Glad You Asked, that premieres on October 8th. So I think that's coming on Tuesday. So you're going to want to see it. You're going to want to see all the episodes, but we're getting a sneak preview today. So we have our guests, scientists with us, and members of the production crew from Vox Media, and we're very excited about that. So they'll be joining us on stage. And then after that, Elon's Starship takes shape. How many of you saw that press thing? Was that not breathtaking? Very cool. So we're going to tell you all about it. NASA opens rover naming to kids. Any kids in the audience? I've heard some kids.
Yay.
Yay, kids. You get a chance to win a prize from NASA, not our crummy stuff. Anyway. Oh, Bill, I'm sorry. I'm sorry. No. Actually, a lot of our stuff came from NASA, so I shouldn't diss it. And then in the second half, we have a bunch of talks, Extreme Makeover Planetarium Edition. If you haven't been to our planetarium lately, you're going to want to go soon because we have some brand new exciting stars. I'm not going to read them all. Is Europe hiding a continent? The day the dinos died. We try to make it sound dramatic. Let's keep an eye on Loki. That's always a good idea. Anyway, on you can see is Planet 9, a black hole, return of Patrick's dark planet. It's just very spooky because it is October, and so we're trying to make it as spooky as possible. So with that, let's just get started. And Patrick, why don't you tell us a little bit about what's in the sky this
Okay,
month?
so what's in store for us in October in the night sky? Well, we'll start with this picture because I took this last night. And if you were out last night, you would notice that there was a bright object just below the moon, and that was the planet Jupiter. If we go to the next slide, there it is identified. And I don't have to identify the other planet because our telescope demonstrator is a laser pointing to it. It's the planet Saturn. So these are the two planets that are prominent in our evening sky. All you have to do is look towards the southwest way after sunset, and you'll be rewarded with a view of these two bright planets. And some stars if the sky is a little bit clear, especially here in Los Angeles. So how about tomorrow? Well, tomorrow the moon will have moved over towards Saturn, so it's going to be right next to Saturn. And you should be able to see that. And if you come to the observatory tomorrow, we have a star party where members of the Los Angeles Astronomical Society and other astronomical societies will set up their telescopes, and you can look through them and get an exciting view of Jupiter and Saturn throughout the evening tomorrow. Through a medium-sized telescope, this is what looks like the two planets photographed. Through a telescope, you can visually see the equatorial bands of Jupiter and the rings of Saturn. So if you've never seen the rings of Saturn through a telescope, it's worth taking a look. If you're coming in tomorrow, do take a look through our telescopes. You'll be really wowed about seeing the Saturn's rings. Now, here's a challenge for you. Venus is slowly kind of emerging out of the evening twilight, and you should be able to see it. So on October 29th, the moon will be just about 4 degrees above Venus, and if you start looking towards the just north of southwest, you should be able to see a bright spot in the sky. It's not an airplane, it will be the planet Venus. And you can track that all the way down towards the horizon around about 6:30. It should be a beautiful sight. A pair of binoculars will definitely be able to see it through binoculars. And also, if you can try and catch a glimpse of the one-day old moon, you'll see mostly a lot of earth shine. So that's something that's worth looking for. In fact, on Monday, our astronomical observer, Tony Cook, took this picture. And you can see that little dot there. That's the planet Venus in a bright evening twilight. It's very hard to see. Once you see it, you can just see it as a little tiny pinpoint of light, but it's just visible. But it's more visible towards the end of the month. So just go out and you'll be able to see Venus emerge from the western horizon. So let's take a look at our moon phases. Well, we have various moon phases, and one of them I wanted to point out is the last quarter moon on the 21st of this month. And you can see that in the early morning sky, so let's take a look at what that looks like. There's the last quarter moon right there below the constellation of Gemini, below these two bright stars, which are the heads of Gemini twins. This is Castor and this is Pollux. And our winter favorite constellation is Orion the Hunter. You can see it's 3 stars in a belt. You can use the 3 stars to point to this bright star called Sirius, which is the night sky's brightest star. And it's kind of low, and you can see it flashing in all colors of the rainbow. That's because of all the heat rising from the ground. So some people call in and say, well, I've seen this colorful star with all different colors. What is it? Well, that's the star Sirius. And you'll be able to see that emerge in our southern skies later in the month. In fact, early in the morning, just a few weeks ago, I took this picture, so you can see the constellation of Orion. There's its 3 stars for its belt, 2 stars for its shoulders, 2 stars for its feet, just above the haze and the light of Los Angeles looking towards the east. Now, on the same morning, you might be able to catch a meteor or two from the Orionid meteor shower. It's not a major shower. It produces just about 20 meteors per hour in a clear, dark sky. But remember, on the 21st, there's that moon in the way, the last quarter moon, so you might be rewarded with 1 or 2 bright fireballs. But that's your sky report for this month.
So before we leave this picture of the sky, a lot of times we like to point out different constellations to help you start to learn them. And this one, Canis Major, means the big dog, although this is kind of a little dog, just to help you remember it. Don't know if you saw that.
Is that the great puppy?
That's the great puppy, yeah. Not in the constellation Puppis, however. So, David,
Yeah.
the next topic I know on the list was Interstellar Visitors. So you want to tell us about who's coming from outside our
Sure.
solar system?
Sure. Well, we had an interstellar interloper before. This long sort of, people were calling it cigar-shaped, but that's probably a little too thin and long. But Oumuamua that came through our solar system and flew right back out the other side. We actually saw it as it was leaving. We didn't see it on the way in. Well, another one has been discovered. And this one doesn't have a flashy animation like that last one did. But it does have, if you look carefully, you can see that there's a bit of a tail. There's a bit of a glow around it. So this one, unlike the last one, is behaving like a comet. The first one didn't seem to give off any gas. This one actually is. The trajectory of it coming in is coming from above, path shooting down through. It was discovered by this telescope, by this gentleman, Borisov, Mr. Borisov. The telescope is only 0.65 meters across, so it's not a very big telescope. He makes these himself to go hunt for comets, but this one he's found seems to have come from another solar system. It didn't come from our own neighborhood, came from somewhere else. The last one that came through sort of looked like this. It was very long. We think it might have been maybe rocky, but there was really no data about that. There were some measurements, but we did have Professor Jewett from UCLA here to talk all about this. And he
Was anyone here in that audience when he came? Yeah.
Awesome. Well, terrific.
Great.
Thank you.
Well,
for
then you
coming
might
back.
remember this.
Might remember this, exactly.
Point is, it doesn't matter what I think or you think. We'll know because we're going to detect more of these things. So my prediction is you'll find another one within a year, something like that, of this size, small body like this.
Yes.
So we'll know.
So we'll know. So he was predicting that there might be 10,000 of these in the solar system at any given time. And if that were true, we should see another one on order of around a year. Well, it's been about 2 years, but still, that's pretty good for astronomy. A year, 2 years, they're pretty close, pretty same thing. So this telescope here was the one that discovered the other one. This is the Pan-STARRS telescope, and it's 1.8 meters across, so a little larger. It is a survey telescope, does lots of surveys, but it just goes to show you can have a kind of a small telescope, the 0.65 one, and still be making discoveries, finding comets and things, so it's somewhat exciting. This is a little animation showing the two of them. They didn't come in together, of course. It's just comparing the two orbits. The red one is Oumuamua, and the yellow one is this new object discovered by Borisov. Oumuamua came closer to the sun. That's why its trajectory changed direction so rapidly and quickly. The other one is coming by a little further out. They both are traveling very quickly, however, and that's how we know for those distances from the sun, those speeds are so fast, the sun can't slow them down and bring them back again. They're going to travel out and never return. These are some other comets. Well, Sedna we know is out in the Kuiper Belt. It's a dwarf planet of sorts. Actually, I don't know if Sedna is an official dwarf planet. I don't think it is. Anyway, its velocity out at 200 AU out there is 1.99, where Oumuamua was traveling at 26 kilometers per second at the same distance. So 10 and a half times faster than an object that's bound by the solar system there. So you can see some comets that are traveling quickly because they fell in from even further out, but they're still not traveling nearly as quickly as these ones. Some color images were taken of this new object. However, we don't have any data on that yet. The papers haven't been written. I'm looking forward to it. This is the color diagram of some of the objects out there, asteroids, Kuiper Belt objects, comets, active centaurs, but Oumuamua is this black spot. And even though it's kind of part of this greater bunch of red-ish objects, they're certainly redder than, the sun, which is the yellow dot on there, but it's bluer considering compared to all the other ones. So some science can be done, although Oumuamua flew through the solar system left, so we didn't have very long to study it. This new one, however, we saw on the way in, so people could get ready and have the telescopes ready, plan observations. So I'm expecting to see more on this one. This one also is outgassing. It has that coma and the tail around it, so it'll be having emission lines, and they even have detected cyanogen, C2N2, coming off of this, which is a little bit of a poison gas. So, and it's been officially named, by the way, 2I, Borisov. So it has been officially named after the gentleman that found it, and 2 eyes for the second interstellar object. The first interstellar object, Oumuamua, there's the information about it. I'm not going to read it all to you, but 1/4 of a mile in length. The other one we think is maybe 0.44 miles to 2 miles wide, so a little bit bigger. Maybe that's why it held on to its ices a little better, although we don't know much about either of the objects. Borisov is still inbound. But we did notice that the one is 1 eye and the other is 2 eyes, so why does it have, they both have 2 eyes? So we fixed that. And then we thought, well, if we're going to give it an eye patch, we probably ought to go full Halloween and give it a parrot and a pumpkin to go trick-or-treating. So.
So David mentioned that that Borisov could hold on to its ice, and we've talked about that in these shows before, that there are a lot of icy bodies in our solar system, like comets. We don't often think of our own planet Earth as an icy body, but in fact, Earth is an icy body. We have icy poles. Sometimes they're larger during the ice ages, and in fact, you may not be aware that there was a time when the entire planet was covered with ice. They actually nicknamed that Snowball Earth. So, when you think of these ice worlds out there, Earth was actually once an ice planet. But it is not now. We're in an interglacial period, and that means that we've been able to adapt and live quite comfortably on the surface and throughout all of the latitudes most of the latitudes of the planet. But just this past month, there was a big report that came out about the state of the ice and the oceans on this planet. What?
Water.
Cool water. That wasn't what it's for, but I'm going to let you have a prize anyway. Because there's another story that might have cool water in it. But anyway, thank you. So this is trying to understand what's the relationship, how is our planet changing, how is the ice changing, how are the oceans changing in light of the change in climate. This report was done by the IPCC, Intergovernmental Panel on Climate Change, which has been around for, I think since the late 90s, so over 20 years, convened by the UN to try to understand the nature of climate change, evaluate using scientists from around the world. Thousands of scientists from around the world signed off on and agreed to by 195 countries. All have to sign off on these reports that the methods were sound before they're released. So it's a UN product. It takes quite a bit of effort, but it is also highly reliable and represents the best science we have. So as you are certainly aware, news isn't fabulous. The Arctic sea ice has gotten quite a bit worse. What you see on the left is the usual yearly change. It's lots of ice in the winter, less ice in the summer. But you can see that 2019 is really dipping almost as low. The worst here was 2012, but it is getting, we've had a lot of ice melt, sea ice melt this particular year. On the right, you can see what's up with Greenland, and you probably saw a video of this earlier in the year, but Greenland's ice, same deal. The red line here, 2019, very bad year, lots of melt this year. The gray is the average from 1981 to 2010. So you can see we're really losing a lot of ice from Greenland, and in recent years in particular, it's just taking a nosedive. Also taking a nosedive is the ice in Antarctica. We talked about this about a year ago, that the rate, not only is the amount of ice thinning and dropping and we're losing ice on Antarctica, but the rate, which was 1 level, has that sort of knee in it, and it's sort of dropping down precipitously. So we're losing a lot more ice, and we're losing it a lot faster in Antarctica as well. So this study looked at the models and the predictions. I'm not going to go through this very tight thing. All I want you to look at is that the stuff on the left goes up. That's basically saying about temperatures, and the 2 different scenarios. The blue is if we can meet the standards of Paris, and the orange is if we cannot. And so I'm going to come to those details. You don't need to try to read that graph. All you need to see is the stuff on the left is going up. The stuff on the right is going down, and that is, those represent acidification. The oceans are getting more acidic, and loss of oxygen, which is really important for the creatures that live there. So without going into any detail, the short version is that global warming is happening. Sometimes I've had people walk out at this point because they don't like to hear it, but it's happening. And I'm going to talk a little bit more about that. This is an animation that shows the temperature every month of every year from 1850. And you can look at the numbers go up, so do the change in the colors in the rainbow. You can see that the temperatures 100 years ago were much cooler. If you look at those red circles of 1.5 and 2.0, and we're approaching that 1.5. Actually, the mean right now is about 0.8 C above the average from pre-industrial times. So the planet is getting warmer, and that is driving changes in climates everywhere. People often ask about those two phrases. They both are true. The planet is warming and the climate is changing. I'm not going to demonstrate any of these things. I've done it many, many times in All Space Considered before. The climate is changing because the globe is warming. Weather is not the same thing as climate. The scientific basis is not complicated. Sometimes they like to obfuscate things by saying, well, the models and it's detailed. It's not. Greenhouse gases block cooling effects of radiation from the infrared. And a lot of times people will say, well, it's happened before and it'll cool again. And the fact is that it hasn't. We've talked in previous shows that it is unprecedented what we're seeing now. Moreover, it's not just about the absolute temperature, it's about how quickly things are changing. And things are changing very quickly. In a matter of 100, 150 years is nothing in geological time. It's the same as one day. So the climate change you saw with the dinosaurs extinction that happened in one day and the days that followed, but I mean an event that happened one day, but a rapid climate change, it's the same time scale. It's 150 years. David made a joke about astronomy, 1 year, 2 years. Really it's more like 10 years, 100 years, that's the same number for geology. So it's the rate that matters. And finally, it is anthropogenic. It can't be explained without human forcing, which is the phrase that people use in models. As I said, I'm not going to go in all those. I just wanted to make sure that everyone knows that's, we have talked about this extensively before, and we are, in fact, going to edit together previous shows and put out a little on our channel, on our YouTube channel, a little Climate 101. Yay, thanks. So all of these things are in reports. These are IPC, but also the World Meteorological Organization, and there are U.S. We just had a study recently from 13 different U.S. agencies, so on and so forth. But I want to talk about two last things. The first is the report, because you're hearing about it in the news now, and I want you to know where these terms come from. The first is a report that came out in October of last year. The Paris Accords, the Paris Climate Agreement, said that we needed to keep, by the end of the century, the temperature to quote unquote, well below 2 degrees centigrade above pre-industrial times. So that number, how much are we heating up, is measured in degrees centigrade. You always hear it in that instead of Fahrenheit for us crazy people. So 2 degrees centigrade, but they said well below. So the IPCC was commissioned to do a study about the difference between 1.5 and 2. And so that difference, that study is here. We are now about 0.8 above pre-industrial times in temperature. And these numbers 1.5 and 2, as you can see, give different examples or different results. The colors here are scale with how bad it is, bluntly, and the redder and the purpler, the worse it is. So certain things are already in trouble. Threatening ecosystems, we're verging on that. Coral die-off is already happening. I'll show you a picture of that in a second. But it really makes a big difference between 1.5 and 2 in terms of what the effects are. Right now, if we make no changes, we are on track for 3 or higher. So if you look on that, you can see it's not good for a lot of things, and it gets worse. I promise I'm going to come back with some happy news in a minute. It does get worse. Anyway, here's a picture of the coral die-off that we're already seeing. This was a massive die-off in the Great Barrier Reef in 2016 and 2017, a bleaching as they call it, and whole systems are, well, I guess I'm sounding like Greta, whole ecosystems are collapsing, and there's a picture of one. The other paper that I wanted, or other result that I wanted to touch on, was this paper we talked about last year called Trajectories of the Earth System in the Anthropocene, otherwise known as Hothouse Earth. That's how the BBC described this paper from the National Academy of Sciences. And basically, Hothouse Earth says that if we keep in this path, we are going to get stuck in a very hot situation. There isn't a lot of recovery. And the idea is because we're reaching a tipping point. That's another word you've heard in the media a lot in the last 2 weeks. The idea here is that at different temperatures, whether we're looking at between 1 and 3, 3 to 5 and 5, these different effects happen. So between 1 and 3 degrees, we'll lose our ice sheets everywhere. And between 3 and 5, we lose our forests, and our circulation of the ocean gets disrupted. Now, the bad news about this is that these have positive feedback effects. In other words, as we lose our ice sheets, Earth as a whole becomes less reflective and absorbs more heat. So when those ice sheets are gone, the rate of warming of our planet increases. That's called positive feedback, meaning you do something, it gets worse, which makes it get worse faster, which makes it get worse faster. Similarly, we lose our forests. Well, the forests soak up so much of our CO2. The forests and the ocean are the big sources, or the big sinks for the carbon in the atmosphere. If we lose our forests, then they're not there to scrub the CO2 out of the atmosphere. And then that finally leads to some of the worst stuff, which is if we lose all the frozen tundra in the Arctic regions that are holding just billions of tons of methane, then we're really toast, literally. And the idea here is that normally we go through a warming period, and then we go through a glacial period, and then we go through a little bit of warming. And the reason this is on this little kind of graph is that there's a feedback that the more we warm, then it cools off. Has to do with the way carbon cycles through volcanoes and back into the Earth's atmosphere and so forth. But as you can see, this little tipping point, if we go past this and we go sailing into this regime, and those positive feedback, we don't get negative feedback, we don't get stuff to cool us off again, things just get hotter. This paper from the National Academy of Sciences talks about the fact that we will be stuck for thousands of years in this very, very serious heated regime, which is completely disruptive to our ecosystems. So this is why you hear a lot of talk about 1.5 degrees, 2 degrees. There is a difference. That was the conclusion of that IPCC. And also because not only have those impacts that I talked about on the different systems, but you start getting into this hothouse Earth regime. So global warming is happening. We're heading toward a tipping point. In 12 years was the paper. So when you hear that in the news, we've got 12 years left, it's not just trying to scare the children. It's referencing this work that says if we don't put a curb on it by 2050, we're not going to make this, and we will go past that tipping point. So, of course, that was last year's paper, so in fact it's 11 years. I had a video of puppies and things. I don't know what happened to it. Yeah. So we'll just go on. I'm sorry, I always wanted to show you cute puppies so you'd feel better. So imagine cute puppies in your head. There, isn't that better? So lastly, Nature came out with an issue devoted to a lot of all about climate change. And I learned from reading this, it's because Nature is part of something called Covering Climate Now, which is 250 media organizations that had determined together to talk about climate change and publish a lot about climate change in the week leading up to the UN meeting last week. So Nature did its part, so did Vox Media. So I just want to say to our Vox folks, I was drawn to this title because I love 12 Excuses for Climate Inaction and How to Refute Them. And then I looked, and who was it from but Vox Media. So we have our visitors today, but they are also part of this coalition. So there are a number of articles. I'm not going to go through them all. Act now and avert a climate crisis, the hard truths by the numbers. So if you are really interested, you can get Nature magazine and read it. It's thorough, it's wonderful. And there are a lot of stories about thawing and so forth. There's an article about changing the Paris Agreement, which is trying to avert or give a temperature limit by the end of the century, because part of the way people are dealing with it is like, well, you know, we can overshoot our target now because in the second half of the century we'll develop scrubbing technologies. And there are a couple problems with that. The scrubbing technologies don't exist, and secondly, we're putting the burden on our grandchildren, our children and grandchildren. And so they talk quite a bit about intergenerational justice, and we've heard quite a bit about intergenerational justice this last week. I also loved that there were a couple sort of personal reflections, why I welcome a climate emergency. I feel very similarly. I gave a talk 2 weeks ago at Mount Wilson. I know some of you were there. I see you there. Thanks for coming to that talk. And in the question and answer, I had to admit I suffer from eco-anxiety. And a lot of scientists do, because we see what this is, and hasn't been able to catch on. So here they refer to it as ecological grief, the people studying the Great Barrier Reef, how hard it is for them. So there is good news, obviously renewables. You can tomorrow go online to LADWP and sign up for green power. It's 3 cents per kilowatt hour more, and that pays for the sort of surplus of cost of drawing money or drawing your power from green sources. We talked in here about planting trees, the necessity of it, and since we'll have some furry animals here, we had the importance of participating in democracy and making your voice heard. Beyond that, there's also direct action that we're seeing more and more. This is the ship or the sailboat that brought Greta Thunberg into the United States. And how many of you saw her speech to the UN? It's remarkable. I couldn't agree more. And if you haven't seen it, I very strongly encourage you to go see it. We're going to show a little clip of it, somewhat altered, in a second, but we would like very much for you to go take a look at it yourself. So she herself said, in reference to that speech, I have moved on from this climate thing. David, you found this video. Do you want to tell us what this is?
Well, yeah, she just said from now on I will be doing death metal only. Somebody took her speech, distorted her voice through a lot of the distortion that these death metal singers will do, and, well, I think we may as well just play it.
Yeah. So I'm going to tell you that while we play this, we're going to make a little scenery change here, but this will keep you entertained while we make our change. Here she is. There's the Greta medal, and here's the video.
What's your message to world leaders today?
My message is that we'll be watching you.
No.
Where's my water? Ready? Sure.
So, of course, we adore that she tweeted herself and said, I've moved on. This is my new life. So, again, I do want you couldn't really make out what she was saying. And if you don't know what she was saying, it is so worth it. So please do go have a look. So to that end, a lot of people think if we really screw up on this planet, we got to move to another one. And I will come back and visit that question in a minute. But let's ask the question first, can we survive on Mars? Is this just crazy? Well, it happens that the people sitting here to my right have been spending quite a bit of time investigating that question as part of their new program. And so I am going to take a moment to introduce them and then let them explain what it is they've learned. So first, next to me is Dr. Robin Bond, who is, as I say, an astrogeochemist.
Yep,
yeah,
I'm adopting that.
Yeah, she's a geochemist who works on astrobiological topics, so, why not put more things together? That goes down to you guys. And then Cleo Abram, Joe Posner, and Lindsay Perna are from Vox Media. Cleo is the host and on air. You will see her in the clip we're going to see. Lindsay is the showrunner, and I'm sure everyone in this room knows what that means, but that means she makes the show run, does the day-to-day, makes it all happen. And Joe, I think you're the executive producer and producer?
Yes.
So actually, you're an executive producer too. Anyway, I'll let you guys do all the intro, but do tell us, can we survive on Mars, and tell us how this all came about.
Yeah. Well, first we want to show you a short preview. This show that we've made, Glad You Asked, is premiering on Tuesday, so you'll be seeing the full 22-minute episode then. And we're so glad that you invited us to be part of this incredible event. And yeah, this show takes on really important, I think, interesting, curious questions about human experience. And I don't know, I think you already explained what the kind of why we're here. So maybe we should just watch this 7-minute clip, and then we'll come right back and talk about it.
Let's see the show.
We're in the middle of an ancient lake basin that scientists think is one of the most Martian places on Earth. And we're stuck.
We're stuck here because I had a question. NASA says the first humans will set foot on Mars in the mid-2030s. It will be the most dangerous mission any human has ever taken. My question is, what comes after that?
Mars!
Not how do we get there, but how do we survive once we do? Okay, here we go. We've been dreaming about Mars for hundreds of years. In the 1870s, Italian astronomer Giovanni Schiaparelli mapped channels he saw on Mars. In Italian, channels are canali. The word was mistranslated into English as canals, implying deliberate construction and flowing water. Other scientists published their own maps, feeding this obsession with the idea that Mars could be a lot like Earth. People were skeptical, but they sort of wanted it to be true. It became a public obsession. The LA Times ran this piece in 1907. Scientists now declare that the many lines and dark spots on Mars represent a most wonderful canal system, which the inhabitants of the planet have constructed for purposes of irrigation. And I just love this headline in the New York Times. Martians build 2 immense canals in 2 years. They're just reporting on this stuff as though there are Martians. This article includes a bit of reasoning. So taking is the notion that mankind has a cousin dwelling on Mars, that men and women of all degrees of enlightenment eagerly hope that it all may be true. People just want to believe. The movies they made in the early 1900s depict a Mars that's not just habitable, but inviting. 1918, this is a silent film. A couple of guys get to Mars and, oh, surprise, they find a ton of beautiful women. They don't hate it. 1930.
So this is Mars. We got a spot like this 3 miles from my hometown.
1952.
Look at the canals.
This isn't so different than sci-fi today. But without any real pictures of Mars, there was still this sense of possibility. Maybe, just maybe, Mars would be something like home. And then this happens.
In 1965 and then again in 1969, NASA sent spacecraft to fly by Mars and send back scientific measurements, and close-up photographs. But the pictures of Mars showed a world of total desolation. There were no canals, no cities, no areas of cultivation, no possibility of life.
I can't imagine how devastating that must have been. I've only ever lived in a time when we had pictures of Mars. Those images were concrete proof that Mars wasn't gonna be the second home that some kinda still hoped for. But we never stopped obsessing about life on Mars. That YouTube clip, David Bowie's music video for Life on Mars, had its highest view day when Mars was visible in the night sky in January 2019. We're still looking up at the red planet and wondering about life surviving there. So let me show you what we actually now know about Mars. We're about to head out into that desert because we're accompanying astrobiologist Kendall Lynch as she does research into extremophiles, which are microbial life that live in, well, extreme environments like this one. And we're gonna ride those ATVs, and I've never ridden one before.
Yeah, we're gonna have to stop. Yeah, he's stuck. Yeah.
Since we're stuck, I'm gonna tell you a little bit about where we are. This place is one of the closest analogs that we have to the type of environment that Mars used to have. Mars was once a wet planet. It had liquid water on its surface.
When all that water went away, Mars still had an abundance of groundwater that stayed liquid, and we still think it might be there in the deep subsurface today, very, very deep. So this is a good model for us to understand how life would survive in this kind of environment on Mars.
It certainly looks Martian.
Yeah. Hey, Camille, you wanna get some gloves on? We're gonna do some science here. So we're just gonna go ahead and take a nice surface core so we can actually do some really heavy DNA extraction and look at who's living in these sediments and what they're eating.
And what is it about the microbes that are living in these sediments and what they're eating that makes it useful for potentially humans to survive on a place like Mars?
Well, if we can understand how life survives on Mars, then we can understand how better to survive ourselves. We're trying to study these microbes called perchlorate reducers. It's, this perchlorate, it's a chlorine molecule surrounded by 4 oxygen molecules. It's toxic to humans, and Mars has a lot of perchlorate. The number one thing we want to use on Mars is water on Mars. And perchlorate likes to go wherever there's water. So we're going to have to figure out how to get the perchlorate out of the water if we want to use that water. It would help us to learn how microbes can kind of mitigate things like perchlorate, and maybe we can use that knowledge to help us detox the resources that we want to pull out and use from the Mars environment. We want to live within the environment on Mars. We want to utilize resources on Mars to help us live because we can't take everything we need with us.
Okay, so Kenda's research will help us use Martian materials to survive on Mars.
So, Robin, I'm going to start with you. Right. We'll work our way backward and broader, but we just saw at the very end there are clues inside that Martian, desolate Martian, Utah, but Martian-like landscape that will help us survive. So tell me more about the research. I should say this is a collaborator of the woman in the video.
Yeah. So I am not in that clip, but I have been out to Pilot Valley a couple of times. And so the thing that we have to understand, first of all, if we're going to look for life, which I know a lot of people are interested in, if we want to look for life, we have to know what we're looking for. I think there have been some really cool sci-fi shows, I can think of Star Trek or whatever, where people don't understand what's happening because there's something alive, but it's not what they thought was what alive looked like. And so we could do the same thing. And it helps us to focus down on what might be there. And what survives in an environment is really based on the chemistry of the environment. So for example, we run on oxygen because there's a lot of oxygen. If you go down even just like, it's, I think, the easiest thing that most people are familiar with, but if you go down to some like wet mud, if you pull up some wet mud that's been buried at the bottom of like a lake or something, it stinks, right? Because there's no oxygen down there, and so they're doing different chemistry. And in fact, we get a lot of that same stuff out in the middle of Pilot Valley. They're all nodding because it smells like rotten eggs. And Kenda likes to say, that's the smell of astrobiology. Because there's a lot of sulfate reducers out there. And we think that there are sulfate-rich environments on Mars, which is one of the reasons we went out there. And then we discovered there's also a lot of perchlorate out there, which that they also have discovered a lot of perchlorate on Mars. We normally think of perchlorate as rocket fuel around here, so it is something that you have to be very careful, like we think about, why would you use rocket? Well, rocket fuel is rocket fuel because it has energy that is stored, and so microbes can actually tap into that energy if they have the right enzymes to deal with it.
So can we tap into it if we were to get to Mars somehow? Is that part of the logic here?
Well, so there's a whole bunch of things that we could do with it. In terms of survival, we can't process perchlorate, right? But there's always a question of, what are people going to live on out there? So you can't, like when I think about survival on Mars, I don't ask, is it possible? I know it's possible. The question I always ask is, how much energy do you have to put into it, right? If it's possible to grow things, is it possible to grow things, food on Mars? Or do we have to haul all the food in from Earth, which would obviously be more energy intensive, and then that would make it harder to just live, right? So if there is something, for example, I cannot think of a way that we could eat the perchlorate-reducing bacteria, but it's possible that you could set up a ecosystem that has that as perhaps as the base of the food chain, and then maybe you could have something that you could actually eat. I'm just kind of coming up with wild ideas.
But that's just what scientists do, right? And then investigate whether it can be true.
We love thinking about like all the possibilities. It's like our favorite thing to do, just sit around and
and then figure out ways to test it.
And figure out ways to test it, yeah.
So, what did you find in those soil samples, or have there been any results yet, or is that just recently?
Yeah. No, it's not recent. I think our first Pilot Valley paper came out in 2015, so it's definitely out. It may even be open source at this point because it's been out long enough. Not 100% sure on that. But yeah, so we have been looking at the chemistry for a while. I think the perchlorate bacteria paper that Kenda published, by the way, these are bacteria we have not seen anywhere else, so they're novel, just came out, I think, is the beginning of this year is when that came out.
So there are bacteria just specific to that desert?
Yes.
Very cool.
And so a lot of what you'll find is that when you have a novel environment, you're going to get things which are very uniquely adapted to that environment. And so it helps us to understand. That's why we go out looking for environments that are very close to Mars, because it's way easier to get to Pilot Valley than it is to get to Mars. Even though it's hard, it's not easy to get to Pilot Valley, but it's an awful lot easier to get there than to get to Mars.
And in fact, in the end of the episode, spoiler, they do get out.
They get out.
Well,
because Cleo is here, so so that's good. So yes, the focus here is we can't carry everything, so we need to adapt and figure out what organisms have adapted. What else do we need? And Cleo, can I ask you, what else is in the episode? What else did you learn? Because you were the one pursuing this question about what we need to survive on Mars.
So we set out to find out whether we could survive on Mars, and as a non-scientist, I was not convinced that this was possible, but learned over the course of the research that it might be. But in doing this research about all of the ways we could potentially survive, what I ended up learning was a lot about all of the many ways we could potentially die on Mars. And that was also fun. So for example, very early on in my research, a very helpful scientist sent me a chart, which was the boiling point of water as a function of atmospheric pressure. Some of you already know where I'm going with this. It might not sound like the most thrilling chart in the world, but what it shows is that the boiling point of water on Earth is about 212 degrees Fahrenheit. Someone fact check me on this, yes? And then that's at sea level, right? So my parents, for example, live in Telluride, Colorado, which is about 8,750 feet. It's very high up, and their boiling point is about 210 degrees. So the higher the atmospheric pressure, the higher the boiling point, and vice versa. Mars has an atmospheric pressure so low that the boiling point of water is below our resting body temperature, which would be a problem. Which means that if you stood on the surface of Mars, the water inside of your body is just going to start to spontaneously boil inside of you, which is why you need a suit. And that is just one of the many, many things that we would have to work on if we were, in fact, going to survive on Mars. The thing that really surprised me in doing this research is that the scientists that I spoke to are so totally convinced that this is possible, that the scale of human ambition and creativity is such that this would be something that we could do. And you know, we talk a lot about the way in which this is like explorers that sailed across the ocean to new worlds. And in some ways that parallel really does hold up. In other ways it completely falls apart. We would be the first life that we know of to deliberately go to another planet and stay there for any period of time. And that is just something so completely unlike anything we have ever done before or even conceived of before. And so what I was really struck by in doing this research was just the scale of that ambition among scientists. And that, I think, is the moral that I came away with, the sort of really exciting kernel, was that we do think it's possible. We think that, you know, could be done.
And what do you think is, or what did you discover in looking at this is our biggest challenge, do you think?
Oh, wow.
I mean,
I think Robin is probably
much
better person to answer this question.
No, and feel free to answer. You know, if you're going to boil, get a suit and a habitat. If you're going to, you know, so, but things that are real showstoppers or could be showstoppers.
One of the most interesting things that I found that I was not expecting to find, I thought that I was going to tell a story about complex engineering and maybe human biology, and the story that we ended up telling landed on the fragility of the human mind, and the idea that to survive a mission like this really does require mental gymnastics that we have never done. The idea that we could live, first of all, for 2 years on a tiny spacecraft shuttling through immense amounts of radiation, far from anything that we've ever known. The interpersonal dynamics of a crew. We visited Biosphere 2, which was a very famous confined space study. And lots of things went wrong in that study because the dynamics of the crew were 4 women and 4 men. And one of the members of the team that I spoke to said that what they discovered was that groups of 8 are particularly problematic because they split into factions of 4 and 4, and those factions are incredibly stable. So basically it was a little bit like Lord of the Flies. And that's bad. So, you know, the types of things that we would have to overcome are sort of these grand scientific challenges, but they're also very, very human. And I think that, in the end, strikes me not as the hardest challenge necessarily, but the one that we know the least about, maybe, right now.
So let me move on and ask you, Lindsay, this show is about Can We Survive on Mars? Mm-hmm. Are there others that are about space, or what are some of the other topics that the show will cover?
Yeah, I mean, it's just so interesting that you all kicked off this presentation with Greta, because our next episode that we're working on, Is It Wrong to Fly? And Cleo actually got to be at Greta's arrival in New York, which was great, because yeah, you can talk about that. But in that episode, we're looking into the effectiveness of carbon offsets and are electric planes the future. Are they going to solve this, or are they actually unrealistic? Other episodes include Should We Worry About GMOs? And I bet half of this crowd may think that they're bad for you, maybe not. This is a very smart crowd. Okay, I give you credit. But okay, so they're not. Well, technically, they are. At this point, we know that they're not necessarily unhealthy for you. But what we discover is that the debate surrounding GMOs is much more complex and nuanced, and that there are many other reasons to worry about GMOs and how they're implemented, and that they're not necessarily delivering on their promise to feed the world. So that's an incredible episode that takes us to Hawaii, which was 2 weeks ago. It was great. But the best part about this series is that we throw our journalists into very unusual places. So we threw Cleo into a tank on a ship of cables that were about to lay out the internet in the ocean. To uncover how the internet works. And it's very similar to just throwing her on an ATV. This is what we do. But I mean, another part of our series is that we try to explain these complex topics with not necessarily using animations, but physical animations. And so you guys saw those little signposts, and it kind of hints to what's to come in the episode. But I'm eyeing that paper plane right now because I need it for Is It Wrong to Fly? Yes, so that's up. And
you have to guess a song.
I'll pull the audience and see if they can help me out. Or I'll pay you some YouTube money and get it. But yeah, we do a lot of topics like that. And then also, plaguing questions like why do we cry? What happens when we die? That was very hard. And we're
really cracked the code.
Maybe. You'll have to watch to find out. Yeah, and we're wrapping up production and working on topics like why are we so lonely and is beauty culture hurting girls? Yeah.
So is this a good time or a bad time to be starting up a science program?
I'll take this. Yeah, I feel like my role is I lead Vox Video in general. So we also have a bunch of other series and shows, and this is like the most ambitious one that we've started. But I think it is an incredible time to be starting a show about science for anybody. It's maybe the golden age for educational programming in general, I would argue, at least.
But it sort of seems like it's the golden age for science denial out there. I mean, why is this the golden age for doing science education?
I think that's a fair question. And I think that both things can be true, basically. That at least as somebody that I grew up really loving watching documentaries and working on documentaries and wanting to be part of their production, and it's never been more accessible and more possible to do that. And I think they've never reached as far. So I remember the first couple docs I worked on, I really wondered if more than the people at the film festival ever saw them. And one of the most amazing, it's fine. So it's a double-edged sword right now. But one of the most amazing things is at least for us and for lots and lots of people making video for the internet, it is so shocking how many millions of people will sign up for things that I think in another generation people would have said, this is, who's going to watch this? This is so nerdy. This is so niche. Why should anyone want to know this? And then the reality of real science, I think that the reason that real science will eventually beat out the misinformation is that essentially the receipts and the journey of what your discoveries are, what they look like, is just absolutely compelling. It's more accessible than ever to find and show these stories. Whether you're, people like us, where we've been given this incredible opportunity to do it at a wild scale. But even if you are working in a science lab, you can make an incredibly compelling and popular series. I remember a friend of mine started a show called Creature Cast a few years back from a bio lab at Brown, or there's all sorts of opportunities to just do this work at whatever level you're at. And yeah, I think that it's a real problem that misinformation is it's kind of a talking point, a concern about from a lot of people. And I hope that is something that we all solve. But I believe at least our role towards solving it is just make real, true content, and make it that like it's actually like better, better than the fake stuff.
You know, I think you appeal to a young demographic, and that I think is a particular niche right now, because as we've seen with Greta's sailboat and everything, you know, I mean, her message is listen to the scientists. So I think there is a pendulum swinging or starting to maybe hopefully change course that says, wait, we really do need to listen to the scientists. So it is a great time and a great demographic, because I think people are, young people in particular, understand we really need to listen to the scientists. We have just a few minutes to ask a couple questions of these folks. Do we have any questions? I'll start with you in the, oh, I thought for a second that was a Sox hat. No, okay. If it's not a Dodgers hat, it can't be in here.
Next time. Just going right back to what you were just talking about, are you going to tackle kind of the pseudoscience that can be presented as science, especially the financial reasons that continues to happen in mainstream media?
And I'm going to repeat that, or if you want to, just for the audience that are viewing, are you going to directly go head on with pseudoscience and what the motivation, maybe financial motivation, for those who are proponents of pseudoscience?
I think that, I mean, something that at least I strongly believe is our best work is done as proactive work. And so what this show does is it shows our own process of discovery, and it shows the evidence on screen. And I think that often, like basically shows that don't do that and end up telling pseudoscientists don't have evidence. Like, I really hope that we're just able to outdo them, because I don't, at least there's some research showing that just like the debunking route actually does not work. And so at least our goal at Vox Video is to just make something that is more effective and better and just reaches more people. And yeah, so share it with your friends.
Any other questions? I'll start to this side of the room, because you often get overlooked. Yes.
I just want to offer maybe a topic for your video, because your series. Because everyone walks around with their cell phones in their hands, are we just going towards computers? Like, are we going to become human computers in some way?
Well, I'm very interested in that, because we're sussing out what the episode will be for Why Are We So Lonely? And a big component of it is that our journalists want to look into whether tech has some sort of effect on this, or has loneliness really changed? Is this something that we've seen in previous technology when we had the telegram and radio and what have you? So it is something that we're thinking about. The problem is that we can't necessarily pinpoint loneliness, which is such a subjective feeling, to our phones. But maybe what we can do is look at both the ways that it hurts and helps. And there's some really interesting ways that people are connecting today. We're going to go talk to some older men. They're called Romeos, and they go out for lunch in Connecticut. And they just meet up, and they've met using, actually I don't know how they met. Maybe they didn't use technology, so maybe that's an answer. We don't need technology.
Aren't they like we'll put a chip in eventually in our bodies for something, like, right? And we'll be seeing stuff. There's some things that are out there I've heard before, so I don't know if, like, we can talk.
To answer your question, there is a lot of work that we can and should be doing about the future of technology. So whether it's not, it's part of Glad You Asked. Like, yes, we are very curious too.
So I wish we had all kinds of time to talk all evening, because it sounds like you guys are doing amazing work and studying and pursuing really interesting questions. And maybe now we need to have another show like All Other Things Considered. Oh wait, that's taken, I think, by some other organization. But so you can come back, because I would love to know the answer to where we go when we die, and a number of other things. But before they leave the stage, I just wanted to kind of close the loop about, is Planet A, or if we mess it up, can we move to Mars? And some people think that might be why there's so much interest in developing and sending people to Mars. That is very unrealistic. Would you agree, Robin?
Yes. If we cannot survive here, how are we going to survive in a much more hostile environment?
Now, that doesn't mean there aren't good reasons for it. And so lots of talk and lots of action starting to send us in that direction. This is an artist's conception of a future Mars base that was provided to the internet by SpaceX of its Starship, landed on Mars. And you can see there's a whole thing. We know it's Mars because of the sun. We have seen a sunset on Mars. There's a real picture from a real rover on Mars of the Martian sunset. So they were clever enough to give us the right color sunset. But in reality, that's what their latest Starship spaceship looks like. In fact, we talked just last month about the little star hopper there on the left and how it compares to the vision and the dream of their Starship that will take people by the hundreds to Mars. But there was a landmark just last week, so I wanted to show you a couple pictures of it where SpaceX did roll out their first constructed larger vehicle. So if you look at the second one, not the You Are Here one, but this one with these little guys up on the top, that you will see right there in this picture. Sure enough, they've actually built one made of stainless steel, not carbon fiber composite, which was a big change. There's so much to say on this. I'm not going to say any of it because all of it's on the internet, but I wanted you to be aware if you did not know. Elon Musk rolled it out just last Saturday night on a very, very windy night. There was a lot of talk about, is the thing going to fall over? And it was bolted down. But just the night before, the administrator of NASA put out a tweet, "I'm looking forward to the SpaceX announcement tomorrow. In the meantime, the commercial crew is years behind schedule. NASA expects to see the same level of enthusiasm focused on the investments of the American taxpayer. It's time to deliver." Now, we've talked about this here before, but there are other aspects of that program that are also delayed, and so we just couldn't resist because we are, like everyone else, Elon Musk watchers around here. He was asked by CNN about this, and he's going to use a term called SLS that refers to the Space Launch System, terribly, terribly delayed by NASA. So here's his reply.
Did you take
Did you say
that?
commercial crew or SLS?
He said commercial crew.
Okay, geez.
I mean, interchangeable. How do you respond to that? And did you take that as a dig?
So yeah, he just keeps laughing, and of course, what we cannot understand why this isn't a meme yet. Anyway, I did want to show one other tiny clip from this because I loved it so much, and it speaks to the way scientists think and act, and which may in times be in contrast to the way organizations think and act. But I'm going to play this one last quick clip from Everyday Astronaut.
If somebody can show that we're wrong, that would be great.
Yeah.
If somebody can explain, like, wow, there is a way to make your design better. This is a gift.
Right.
I would be like, thank you for this great gift. Wow, this is awesome. It's definitely like the worst thing would be like we want to do some dumb design and stick with our dumb design.
Right.
So I think that's part of the entrepreneurial spirit. Yeah, that says, criticism is good. We want to learn, we want to grow, we want better ideas. And of course, later in the interview, he talks at great length and with great passion, as if you've seen him before, he always does, about the need to be multiplanetary. Because the Earth does face problems, and it will continue to face problems. We certainly have climate problems. But we're always going to be at the mercy of some asteroid or comet that, as we know, we have a story in the second half about dinosaurs and the day of that mass, the day the dino-killing asteroid hit Earth. So we are making steps to go there because at some point we may he talks about it preserving consciousness in the universe. If we're the only planet where that is in existence that we know so far, then we have a responsibility to preserve it and at least have an outpost where humans can survive. So it may not be cities, it may not be grand civilizations, but we have an obligation to go beyond this world. We are, of course, already on Mars. These are pictures and drawings of the Curiosity rover. The Mars 2020 mission will be launching next year and send another rover to Mars to study this area. I bet you would love to work on that, and you maybe will be working on that.
I believe Kenda has already submitted a science proposal for Jezero Crater, so yeah.
So Jezero Crater, where we think conditions could have been right for Mars. So especially for the young people, or those of you who know young people, there is a contest going on right now to name the rover. There's a video about it during break. And so you can submit at NASA. You'll see in the video how to do that. We know one person who's submitted is Brad Pitt. Why am I bringing up Brad Pitt? Well, because he loves us. And so that was just a couple weeks ago. But he also, yeah. So he's no, I guess he can't submit. Somebody said he submitted his name to, and his name is going to send to Mars, not for the, yeah. Okay, so anyway, that's our little picture of Brad Pitt. So you have to be a kid, you can't be working for the project, and here are the deadlines. November 1st is the main deadline. So you have to write an essay, it's gonna be great, give it some thought. Where's some of those young people that were in here? I think I see some back there. You submit an essay, okay? Okay. Excellent. And then before we go to pretty pictures, which ends the segment, I just want to put in a plug in for next month. We're so excited to have my old lab partner, and I mean young lab partner, Pat Slane, who is with the Chandra X-ray telescope at CFA in Boston at Harvard. And so he's going to, it's 20 years since the Chandra X-ray telescope launched. We're going to hear all about the amazing things that it has revealed to us. So with that, I'd like to turn down the lights, and I'd like to say thank you to our YouTube audience for being with us. We're so glad you joined us tonight. But here's where we all say goodnight. So everyone say goodnight to our YouTube friends. So lights down, lights off.